Yep, guys, welcome back to my channel. This is basically Projectile motion in a nutshell. It is nutshell, but I'm gonna cover everything. That is to be covered. So, without a further ado, let's get into the video. Let's just draw the thing how projectile motion will look like. This is R. This is gonna be the range, horizontal range. The body is gonna go from like this. The angle with the horizontal is gonna be theta. The speed with which it will be through the body is going to be thrown is u. So let's get into work. Right, let's get into work. In this position, there are two velocity components. This is u, this is u cos theta, this u sin theta. Initial velocity is u. If we talk about the vertical component, u cos theta, it never changes. Why? Do you think it really matters what how further we are going, how much distance we are covering, what height we are reaching, for the horizontal velocity to change? No. If a guy is running horizontally, no matter what are the conditions, no matter what are the conditions are, will this velocity change? No. But if he's jumping up, his velocity changes. If one point becomes 0, at another point it drops to the ground. So let's say this. After uh, let's say the body is in motion for t seconds. So t seconds. Let's say this total distance is x and this total distance is y. For t seconds, x equals to wait a second. So velocity in this direction is constant, the horizontal, so it won't change. What is the formula for constant velocity? What is the formula distance if the velocity is constant? S equals vt, right? So similarly, x is gonna be u cos theta, y is gonna be what? Is the velocity constant? When you jump up, let's say, and I throw this pen, velocity changes. At one point it becomes 0, it comes down, velocity changes. So what is the formula for distance if the or displacement if the velocity is not constant? You know this. So we apply the same thing. Look, we got two different cases. One is constant velocity, one is uniform acceleration. Tell me, what is the velocity in this direction gonna be? We told about the components. The horizontal is gonna be u cos theta, vertical u sin theta. So u t, what is g? Let's say g, doesn't matter, minus half minus half gt square. Is there a problem? No, there shouldn't be. Next, we were talking so much about this point. Velocity becomes 0, velocity becomes 0, here becomes 0. What is this here? What is this velocity becomes 0? Where does the velocity become 0? Let's talk about it. You guessed it right. Somewhere over here, the velocity is 0. So let's say that time taken is t or t second. How can we find out this t velocity? That is, let's say the motion is still here. You're considering this part only, this quadrant. It's not even a quadrant. Trust me, it's not even a quadrant. What is the final velocity? Yes, this is. What is the final velocity? 0. So You have to work with either two equations, v equals to ut or v square equals u square plus 2s. Which one? We want to find t, so v equals ut, u plus at, u sine theta, but minus gt. T is u sine theta time taken to reach max height. This is, and we found out t. Let's find out maximum height. What is this maximum height? Let's say this is h. So v square u square minus 2gh. What is this? 0. No. Oh, I forgot. I did a terrible mistake here. We are talking projectile motion, so it's always, if you talk about the vertical, it's gonna be u sine theta, the velocity. So the maximum height is u square sine square theta by 2g. This is the maximum height. We talked about this pen. We're talking about this pen. At this point, the height is maximum. This is the maximum height. The velocity is 0. The height covered is u square sine square theta by 2g. You can also find this maximum height if you know the velocity with which the pen is thrown and the angle. It's going to be close to 90. Of course, it went straight like this. Let's move to the next concept. This is the range. What is this range? We talked about this r. It's correct. This is the horizontal distance covered. What do you think is the time? Is it t, t dash, t, capital T, what? No, we are not talking about time taken to reach maximum height. We are not talking about this t. No. Also, let's do something. We know what this t. We know this t. Can we find the total time of the journey? Of course. Let's multiply this by 2. Did you understand? Did you understand? Why? I'm throwing this pen. It's taking some time to go here. Again, taking the same time to go here. Let's prove it to you. What time? This is the time. Or this is the, let's say this is the time of ascent. Let's say the time of descent. What is the final velocity you think? Use questions. Let's do it. If the body, if trying to find the time taken in this portion, the last half, what do you think will be the final velocity when the body reaches here? Same. U square sine square theta. What do you think is the initial velocity? 0. Talking about this part. Oh, sorry. U. No, we will find u plus at, this formula. So v equals to at g t for time of descent equals to u sine theta by g. Look at this. Time of descent equals to ascent. Total time or time of flight. Just add 2u sine theta by g. Look, you don't have any other variable except u. G is not even a variable. Asked in question, mentioned in question. Let's find the range, right? So the total time, if you again know the velocity of this plane and know the angle which is close to 90, you could find the total time for which the pen was doing this and that, which is 2 to u sin theta by g. Got this. This is independent for each and any kind of projectile motion. Don't record any other variable except the u. And theta, you just have to know the angle. That's it. What is this R you were talking about? Well, this R is the distance. Hear me out. It's the distance covered horizontal in the horizontal direction. So do you think it's gonna be for time? Is it gonna be for u sin theta by g, or is the time gonna be 2 u sin theta by g for this r? If you think it's gonna be u sin theta by g, then considering this distance, but in reality it's 2 times. So we're gonna get the total time. So r is basically cos theta tf, which is multiply theta sine theta by g, which is, this can also be written as, you know what this is, so we can write this u square sine 2 theta by g. It's not sine square theta, remember. This is the horizontal. What do you think is the vertical distance? Come on. What do you think is going to be the vertical distance? Maximum height into 2. You get the vertical distance. Vertical is 2 u square sine square theta by 2g, which gives you sine square theta by g. So you know almost everything, which is just a little bit is left. We'll convert it on the next video, which is the nature of trajectory. So this part is left. We will do it. Alright, so bye for now.